pretty wild, right? The stuff you've been sending my way lately, it really makes you think. Like, what is reality even? We keep bumping up against these fundamental questions, and today, well, today feels like we're diving headfirst into the biggest mystery of them all, quantum physics.
You're not wrong. It's a field that's notorious for making even the sharpest minds go, wait, what? But that's part of what makes it so fascinating. It's like peeking behind the curtain of the everyday world and finding a whole other set of rules.
Exactly. And the implications, from what I've been reading in these sources you've given me, are huge. We're not just talking about tiny particles doing their thing. This is about the very nature of the universe and how we understand it.
Absolutely. Quantum physics isn't just about equations on a blackboard. It's about grappling with the fundamental building blocks of reality. And as we'll explore today, it has the potential to revolutionize not only our technology, but also our philosophical outlook on the world.
Okay, so before we get too deep into the weeds, maybe we should start with a quick overview. Like, what kind of sources are we drawing on for this deep dive, and what are we hoping to uncover?
Well, we've got a pretty diverse mix here. Articles, research papers, even some excerpts from books written by leading quantum physicists. And there's definitely a range of perspectives represented, which is always exciting. But the common thread running through it all is this sense of awe and wonder at the sheer strangeness of the quantum world.
It's definitely contagious, that sense of awe. But before we get to the mind-blowing stuff, can we take a step back and define what we're actually talking about? What is quantum physics in a nutshell?
In the simplest terms, it's the study of the universe at its most fundamental level, the realm of atoms and the particles within them. And it's a realm where the familiar laws of classical physics, the ones we use to describe the everyday world, simply break down. Things get fuzzy, unpredictable, even a little bit spooky.
Fuzzy and stooky. Those are definitely words that keep popping up in my notes. But what does that actually mean? What makes the quantum world so different from the one we experience?
Well, think about how we normally perceive the world. Objects have definite properties. They're either here or there, moving at this speed or that speed. But in the quantum realm, things aren't so clear-cut. Particles can exist in multiple states at once, their properties blurry and uncertain until we actually measure them.
So it's not just that we don't know these properties, it's that they're actually undefined until we observe them.
Exactly. It's like the universe is holding all these possibilities in suspension until we force it to choose. And the act of observation itself plays a role in shaping the outcome.
Yeah, it's a pretty mind-bending concept. But
Yeah.
the sources you sent over also highlighted that it's not just observation that's weird, it's the behavior of these particles themselves. Like the idea of superposition, where a particle can be in multiple places at the same time.
Right. Superposition is definitely one of those concepts that makes you scratch your head. It's as if a single particle could be spinning clockwise and counterclockwise at the same time, or be located in multiple places simultaneously. And it's not just a theoretical idea. Experiments have actually demonstrated this behavior.
So it's not just a thought experiment. It's a real thing that scientists have observed.
Hmm.
That's wild. And what about entanglement? That was another concept that kept coming up, this spooky action at a distance that even Einstein struggled with.
Yeah, entanglement is definitely one of the most mind-boggling aspects of quantum physics. It describes a situation where two particles become linked in such a way that their properties are correlated, even if they're separated by vast distances. It's as if they're communicating instantaneously, which seems to violate our classical understanding of cause and effect.
It's almost like they're two sides to the same coin, even if that coin is split in half and flying to opposite ends of the universe.
Okay.
And this connection, this entanglement, it's not just theoretical, right? It has real-world implications.
Absolutely. Entanglement is actually at the heart of many emerging technologies, like quantum computing and quantum cryptography. And as we delve deeper into understanding it, who knows what other possibilities might emerge?
It sounds like we're just scratching the surface of something truly profound. But before we jump ahead too far, I'm curious about the historical context. How did these revolutionary ideas even come about? Who were the pioneers who first dared to peek into the quantum realm?
Well, as with most scientific revolutions, it started with a few nagging problems that classical physics just couldn't explain. For example, there was the issue of black body radiation, the way heated objects emit light. Classical theory predicted that the intensity of this radiation should increase infinitely at higher frequencies, which clearly wasn't happening in reality.
So the theory and the experimental observations were clashing.
Exactly. And that's where Max Planck comes in. In 1900, he proposed a radical solution. that energy isn't emitted or absorbed continuously, but in discrete packets or quanta. This was a huge departure from classical physics, and it marked the birth of quantum theory.
So this idea that energy comes in chunks, rather than a smooth flow, was the first crack in the classical picture.
Precisely. And then, a few years later, Einstein came along and really solidified this idea with his explanation of the photoelectric effect. He showed that light itself can behave as both a wave and a stream of particles, which he called photons.
So light, something we normally think of as a wave, can also act like a particle. That's another one of those mind-bending dualities. And Einstein, despite his later skepticism about some aspects of quantum theory, played a key role in its development.
Absolutely. He was a true pioneer, even if he didn't always agree with the direction the field was taking. But his work, along with Planck's, laid the foundation for the quantum revolution.
And that revolution led to some truly remarkable discoveries and insights. What are some of the other key figures and concepts that shaped our understanding of the quantum world?
Well, one name that immediately comes to mind is Niels Bohr. He was the one who developed the first quantum model of the atom, proposing that electrons orbit the nucleus in specific energy levels. This model, though later refined, explained why atoms emit and absorb light at specific frequencies, which was a mystery that classical physics couldn't solve.
So Bohr gave us a quantum picture of the atom itself. What about some of the other big players?
Another key figure is Werner Heisenberg, who formulated the famous uncertainty principle. This principle states that there are fundamental limits to how precisely we can simultaneously know certain pairs of properties of a particle, like its position and momentum. It's not a matter of limitations in our measuring instruments, it's a fundamental feature of the quantum world.
So even with perfect technology, there are certain things we can never know for sure.
Exactly. It's a profound insight into the nature of reality at the quantum level. And then we have Erwin Schrödinger, who developed the wave equation, a mathematical tool for describing the evolution of quantum systems. His equation introduced the concept of the wave function, which contains all the probabilistic information about a particle's state.
The wave function, that sounds familiar. It's like a mathematical description of all the possibilities for a particle.
Exactly. It's a way of capturing the inherent fuzziness and uncertainty of the quantum world. And of course, Schrödinger is also famous for his thought experiment involving a certain feline friend.
Ah, yes. Schrödinger's cat, the ultimate quantum paradox. But what's the point of imagining a cat trapped in a box, both alive and dead at the same time?
It's a way of illustrating the bizarre implications of superposition when applied to macroscopic objects. The cat in the box represents a system that exists in a superposition of two states until we make an observation, which forces it to collapse into one definite state. It highlights the strangeness of the quantum world and the role of the observer in shaping reality.
It's still a pretty mind-boggling concept. And we can't forget entanglement, that spooky action at a distance that even Einstein found unsettling. How does that fit into the bigger picture?
Entanglement is a direct consequence of the mathematical framework of quantum mechanics. It shows how the fates of two particles can become intertwined no matter how far apart they are. And it's not just a theoretical curiosity, it has real-world implications for fields like quantum computing and communication.
All of this is pretty far removed from our everyday experience. But the sources you've been looking at suggest that these quantum principles aren't just abstract theories. They lead to some pretty amazing and potentially useful phenomena, right?
Absolutely. Take quantum tunneling, for example. It's the ability of a particle to pass through a potential barrier, even if it doesn't have enough energy to do so classically. It's like a ball rolling up a hill and magically appearing on the other side without ever reaching the top. And this phenomenon is crucial for processes like nuclear fusion, which powers the sun.
So the sun, the very source of life on Earth, relies on this seemingly impossible quantum trickery. That's incredible. What are some other examples of these mind-bending quantum effects?
Another fascinating example is quantum levitation. Certain materials, when cooled to extremely low temperatures, become superconductors, meaning they can conduct electricity with zero resistance. And these superconductors exhibit the Meissner effect, where they expel magnetic fields, allowing them to levitate above magnets. It's a macroscopic demonstration of quantum principles at work.
I've seen videos of that, and it's truly mesmerizing. It's like defying gravity with the power of quantum mechanics.
It is pretty amazing. And then there's the whole field of quantum computing, which has the potential to revolutionize everything from medicine to material science. Quantum computers use qubits, which can be in a superposition of states, allowing them to perform calculations exponentially faster than classical computers.
Quantum computers, they sound like something out of a sci-fi movie,
Yeah.
but they're becoming a reality, right?
They are. And then there's quantum teleportation, which, despite the name, isn't about beaming objects across space like in Star Trek. It's about transferring the quantum state of a particle to another particle,
Wow.
potentially over vast distances. It's a mind-boggling concept with potential applications in secure communication and quantum networks.
It sounds like we're on the verge of a technological revolution driven by these quantum principles.
Hmm.
But for someone listening to all of this who's new to quantum physics, it can be a bit overwhelming. Where's a good place to start? What's the first step on this quantum journey?
I think the most important thing is to approach it with a sense of curiosity and wonder, and to be willing to let go of our classical intuitions. Don't try to force these concepts into a familiar framework. Instead, embrace the strangeness and the mystery.
So it's about letting go of our preconceived notions and being open to a new way of seeing the world.
Exactly, and there are plenty of resources available for those who want to delve deeper. There are excellent, popular science books and articles written by quantum physicists who are skilled at explaining these concepts in an accessible way. Don't be afraid to explore different explanations until you find something that clicks for you.
And what about those thought experiments like Schrödinger's cat? Are they helpful or are they just confusing?
I think they're incredibly helpful. They force us to confront the paradoxes of quantum mechanics and to think deeply about the implications of these strange ideas. And as we've seen, even if they seem bizarre, they often lead to real-world insights and technological advancements.
So embrace the weirdness, explore the paradoxes, and be open to the possibilities. That's good advice for life in general, I think. And as we wrap up this deep dive, I'm struck by the fact that quantum physics isn't just about equations and experiments, it also has philosophical implications, right?
Absolutely. It forces us to rethink our understanding of reality, causality, and the role of the observer. It challenges our assumptions about what we can know and how the universe works at its most fundamental level.
And it opens up new avenues for exploring the nature of consciousness, the interconnectedness of everything, and even the meaning of existence itself.
It does. It's a journey that takes us beyond the realm of the familiar and into a world of wonder, possibility, and profound mystery.
And on that note, I want to leave you, our listener, with a final thought. If the very fabric of reality, at its most fundamental level, is governed by these strange quantum rules, what does that tell us about the nature of the universe we inhabit? And how might these principles of uncertainty, superposition, and entanglement influence our own lives, even if we don't always perceive them directly? It's something to ponder as we continue to explore the quantum realm and its implications for our understanding of ourselves and the cosmos. Thanks for joining us on this deep dive.